All right, folks, good morning. It is May 18th, 2020. That's how many days we've been doing this stuff remotely. All those X's up there. Um, but anyway, uh, yeah, welcome to week 2. So, as I said in the post that I just put up on the classroom page, we are now coming to the end of our first unit, which has been about one-dimensional motion. Um, One-dimensional meaning it's kind of like it goes back and forth, but it does not go up and down, right? It's kind of restricted to one type of motion, just back and forth. Um, so yeah, you had that quiz. Good luck with that. Let me know if there's any questions about it. Um, so yeah, but now we're moving on to kind of the next phase. Now the next phase, right, the next unit is going to build off of what we were doing in the first unit with one-dimensional motion. We're still going to be working with concepts of like position, acceleration, velocity, and stuff like that. But now we're going to get more interesting and start thinking about things that move in 2 dimensions, right? So not just left and right, but also up and down. So 2-dimensional motion is the next thing. As you can see, some of the stuff that we're going to work with, some of the stuff that I'm going to demonstrate involves, like I've been playing with this thing for a while. You pump this up with a tire pump, bike tire pump. And the first time I blasted one of these off, I wasn't sure how high it was going to go, and I was actually pleasantly surprised. It's very fun. So we'll be working with this. Another thing, just a second. Some of you may be familiar with this object. I'm going to be doing some demonstrations with this. So by the end of the week, actually, your next kind of big assignment, your next big sort of like lab type assignment is going to involve something that I'm going to do with this. And so you have that to look forward to. But the thing about it, the two types of objects that I just showed you, this rocket and that football, what governs those objects' motion through the air is this concept that we all know, this concept of gravity, right? So gravity is, it's kind of what runs the universe. You, you can't get away from gravity, right? It's one of the most common and sort of what am I trying to say? We all experience gravity every day, right? It's what makes this coffee pour from my trusty thermos into my cup. Even the path that that coffee is taking as it falls out of the thermos can be, I could predict how that coffee is going to pour out because of what I know about gravity. It's also what keeps the Earth in its nice, almost circular but elliptical orbit around the sun. It's what governs the way our galaxy itself, the entire galaxy, is flying away from other galaxies as everything in the universe is spreading apart. All of that is governed by the same concept of gravity, so it's kind of a big deal. Now, when I showed you that the ramp Galileo in the garage, and I asked you the question why, like, what was Galileo trying to find? Like, why was that the thing that he set up? Like just about all of you, I think, were like in the ballpark. He was trying to figure stuff out about gravity, right? So, for example, we know that if I drop something, like if I let it go from a height above the surface of the Earth, that it's going to fall. We also know that it's not just going to fall in a uniform way, right? It's going to accelerate. It's going to pick up speed. It's going to pick up velocity as it falls up until when it finally hits the ground. So what folks like Galileo were trying to do is determine what is that acceleration, right? Like what is, I mean, because it's not like, it wasn't like written down in a book, right? At some point, people had to actually figure this out. And when, you know, you're doing this 100 years ago, or hundreds of years ago, I should say, um, they don't have sophisticated tools, right? They don't have computers in their pockets, right? So they had to be really careful about how they set up these measurements. That ramp experiment is one way that you can really accurately and carefully determine what is the acceleration due to gravity, right? So we're gonna work on that a bit this week. What I'm gonna ask you to do, right? So all of this is to introduce the kind of experiment that I want you all to do at home. Is I want you to determine as best as you can, right, supported by the data that you collect, what is the acceleration due to gravity? So, so how are you going to do that? Like, how would you do that? Okay, so like I'm really tempted. I kind of just want to like give you all of the ideas that I have about how you might best make this determination. But I also want you to actually think about it, right? Um, I will say that if you have, I mean, the bare minimum of sort of tools that I think you would need is you're going to need something to measure a distance, right? So a tape measure or a ruler or a yardstick or whatever, right? You're going to need something to keep time. So I think just about every one of these has a like a timer app. But if you know, you can use anything you want. If you have like a regular stopwatch, that works too. And then you're gonna need an object. So your object could be anything. It could be a football. It could be I don't know, a dry erase marker. It could be Yoda. It doesn't matter to me, right? When you are finished collecting your data, whatever data it is that you decide to collect, you're gonna. It doesn't have to be super formal, but you know, on a sheet of paper, you're gonna write a paragraph that describes your setup. You're going to have a place where you've collected your data. Okay, you're gonna talk about why you decided to collect that data, and then you're going to use the data to try to make a determination about what was the acceleration due to gravity. Okay, so I anticipate that there will be questions. Um, Hit me up in office hours. You can you can send me an email. You can comment on the you know on the Google Classroom. Um, but I think you know once you finish your quiz should probably take anywhere between like a half an hour and an hour to complete. Um, then you're gonna spend some time, right? You're gonna spend like an hour or two doing this lab, right? And I think what I'd like is for this all to be completed today, okay? So that we can move forward tomorrow with some of this two-dimensional motion stuff using what we've determined about gravity, okay? So I hope that all makes sense. I hope that all makes sense. Let me know if it doesn't, and I will see you later on. All right? Cheers.